Welcome to lectures on problem solving and programming in C. This is the 12th lecture of the course, and the title of the lecture is Taylor series. How to compute approximate values of Taylor series expansions for pi, sin x, cos x, e to the x, and so on. The purpose of this lecture are programming Taylor series expansion is not to compute approximate values of sin x and cos x, but it gives you one way to practice repetition statement, how to use repetition statements, and incrementally how to compute update values in a repetitive statements. These kind of aspects, these are the good examples to practice. Let us first see the infinite series of Taylor series for pi value to approximate the pi value. So it is goes like this: pi to 4 minus 4 by 3 plus 4 by 5 plus 4 by 7 and so on. If you observe here, we can say this is 4 by 1. You can treat this as 4 by 1, 4 by 1, and minus 4 by 3. If you see the numerator is 4 across the sequence. Alternating 4 minus 4 plus 4 minus 4 plus 4. It's alternating 4. The absolute value of the numerator is 4, and the denominator value, if you observe, it is changing by two numbers. 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. So, and also we cannot run this series for infinite number of times. We need to figure out how many terms you want to consider to give the approximate value of pi. Suppose if we say 10 terms I will consider, then you will get a different some value for pi. If you want to consider 20 terms, you will get closer value of pi, like that. So we need to read the number of terms you want to consider for the term, for the pi value, and then accordingly we need to run the algorithm. If you are talking about only one term, it will be, you will get for approximate value of pi as 4, value 4, because we are going to consider only 4 only. So let us try to develop an algorithm for this. Yes. So algorithm. So it's algorithm. Approximate pi. Approx pi. Input n greater than or equal to 1. Output approximate value. Approximate value of pi. Okay, begin. So input input validation. If n less than or equal to 0, then output invalid input, and stop the program, stop the algorithm. And if, right? Otherwise, what we need to do? What is the pi value? Initial pi value is 0. Initial pi value. We are going to compute the incremental pi value incrementally, right? And then what is the numerator? Initial numerator. Numerator is equal to 4. What is the denominator? Denominator is 1, because 4 by 1. Na? Initially 4 and denominator is 1. 4 by 1. Okay. For how many terms you are going to consider? We are going to consider n terms. So for I equal to 1, 2, n, do. Okay. How we are going to update the numerator? What is the pi value? Pi equal to pi plus like plus numerator by denominator, numerator by denominator. So initially numerator is 4, denominator is 1, 4 by 1. So after the first iteration, pi value will be 0 plus 4 is 4. Okay. For the next iteration, how pi value is changing? Numerator is changed by minus, multiplied by minus 1, right? Numerator is equal to numerator star minus 1. Numerator is multiplied by minus 1. It will be minus 4. And for the next iteration, it will be minus 4 into minus 1 is plus 4. It is alternating. The sign plus 1 plus minus will be alternating. Then what about denominator? Denominator is equal to denominator plus 2. Earlier one, for the next iteration, it will be 3. And for the next iteration, it will be 5. So, and for. Then output 5. And end. This is algorithm. So initial value of pi is 0. Now we read the number n and input validated. Initial value of pi and numerator. Every time you are computing numerator by denominator, right? Every term is in the form of numerator by denominator. So it is numerator is 4 for first value, denominator is 1. Then how many times we need to compute how many terms we need to consider? N terms. That is, we have a repetition which runs from for I equal to 1 to n. And then each term basically numerator by denominator, and that will be added to the previous pi value. And then how numerator is changing from the current term to the next term? Numerator sign is changed, reversed. So plus becomes minus and minus becomes minus. That is, we are multiplying number with minus 1. So that it becomes, if it is plus now, it will be negative. If it is negative, it will be positive for the next term, like that. If and how denominator is changing? Denominator is incremented by 2 between the previous term to the current term. That is, we are changing. So this loop runs n times, and then after this loop, pi value is approximated by considering the first 10 terms of the series. Then we are outputting the pi value. This is all. You can write the program for this. So there are a lot of things we need to take care of while writing the program. Just write the program, C program for this problem, and then try for different values of n and see what is the pi value. Okay. Especially you need to take care of the um, this integer division. Okay. Next, these are the different series for Taylor series: e to the x, sin x, cos x. So we will, in this lecture, we will see e to the x and sin x. Okay. Yes. E to the x, algorithm for e to the x. So what is the format? If you observe, so it will be, we can say 1 by 0 factorial, x by 1 factorial, x squared by 2 factorial. You see, it's very similar to previous exercise. What is the input? Input will be x here, and then number of terms n. And then if you look at how you can write like this, this is x to the 0. 1 is x to the 0 by 0 factorial, right? And then how numerator is changing between the successive terms? It is multiplied by x, multiplied by x, multiplied by x. X square multiplied by x is x cube. X cube multiplied by x is x square. Then how denominator is changing? It is basically 0 factorial, 1 factorial, 2 factorial. How do you get 2 factorial, 1 factorial? By multiplying the 2. How do you get 3 factorial from 2 factorial? By multiplying by 3, like this. We no need to compute factorial every time from the scratch. If you want 4 factorial, 3 factorial is already computed. If you multiply 3 factorial by 4, you will get 4 factorial. That is the trick here. So value should be incrementally computed, not from the scratch. Algorithm e to the x, e to x, input n greater than 0, comma, x, output, x can be any real number, output, approximate value of e to the x. begin input n, and input validation, we should do input validation. If n less than or equal to 0, then output invalid input put and stop. And if okay, then input x. No in validation required for x because any value is acceptable. So how many terms are there? What is the denominator? Numerator. What is the numerator? Numerator is 1. First numerator, the x to the 0 is 1, right? 1. What is the denominator? Denominator is 1. 0 factorial is 1, right? Right. How many terms we need to compute? For sorry, e to the x is ex. Ex is equal to the x is equal to 0. How many terms we need to compute? For I equal to 1, 2, and 2. So ex is equal to ex plus numerator by denominator. The first term is added. Okay, 1 by 1, 1 is added. For the next term, how numerator is changing? Numerator is equal to numerator multiplied by x. Multiplied by x. So initially 1, it will be x. X becomes x square. X square becomes x cube, like that. How denominator is changing? How denominator is changing? It is multiplied by 1, then 2, like this. So 1 is basically I multiplied by denominator is equal to denominator star I. Uh, initially 1 factorial. Okay, 0 factorial, 1 factorial. If you multiply by 1 factorial by 2, 2 factorial. 3 by 3, 3 factorial. Like this, denominator changes every time. So and for and output ex, then end. You see here, numerator is changed by numerator is changing by multiplying the previous numerator by x. You will get the current numerator. so 0 factorial, 1 factorial. From 1 to 1 factorial, what you do, you will multiply by with 1, right? So that is why I. From 1 factorial to 2 factorial, you need to multiply it with 2. So when I equal to 2, just need to multiply with 2. So just multiplying the denominator with previous denominator by I, you will get the current denominator. Okay, the simplest solution. Let us see the next problem, sin x computation. Sin x. Okay, algorithm sin x input n greater than equal to greater than 0 and x output approximate value of sin x. Begin in. So input n, input validation, n less than or equal to 0, then output invalid input stop, and if otherwise input x, sin x is equal to 0. Initial value of sin x is 0. What is the initial value of numerator? Numerator is equal to x. Denominator is equal to 1. right? So for I equal to 1, 2, n, do sin x equal to sin x plus numerator divided by denominator. Okay. How numerator is changing from successive terms? Numerator is changing by multiplying with the minus x square. So x multiplied by minus x square is minus x cube. Minus x cube multiplied by minus x square is plus x to the 5, right? This alternate sign coming because of that. Numerator multiplied by minus 1 multiplied by x multiplied by x. Okay. How denominator is changing? Denominator is changing by, you need to see, initially you have 1, you should multiply with 2 and 3. Okay. So when you have I equal to 1, you should multiply with 2, 3. If I equal to 2, you should multiply with 4 and 5. So what you can do is, it's a 2 times I multiplied with 2 times I plus 1. Denominator multiplied by 2i, 2 star I multiplied by 2 star I plus 1. So this way, denominator factorial value is 3 factorial, then 5 factorial, and then 7 factorial comes. Okay. And then n for output, put sin x, and end of the algorithm. Okay. This is the bit trickier one. This is a trickier one. Okay. Right. So in these trial series expansions, even though there is a factorial in the denominator, we are not computing factorial from scratch every time. We are just incrementally computing the factorial from the previous factorial value. This way we are saving a lot of computation. Let me show these algorithms. So this is the approximate value of pi. You see here. And this is approximate of sin x. Its denominator is multiplied 2 star I and 2 star I plus 1. Okay. So I will stop here.